So we covered up definite integrals or integration of limits in the last class or lecture, but we did not cover advanced concepts such as the limits being interchanged, or when we have something like this. That is, we are given this and maybe asked to find this, or we have to apply some other concept or a similar concept to find this. So first of all, let's look at what we do when the limits are interchanged. The concept is simple, that when the limits are interchanged, the sign of the answer changes. If the upper limit is b and the lower limit is a, and the answer in that case when the integral of f of x is solved is p, then if the limits are swapped, the answer would be minus p. Let's take a numeric example because this was a bit generic. So moving on, let's say we have 6x to the limits pi and 2. The integral of 6x would be 3x squared. We have the limits pi and 2. Applying the limits would give us something like this. We substituted the limits, and now we have to simplify this in order to find the answer. So we have 75 minus 12, and we end up with 63. What if the limits are interchanged? We expect the answer's sign to be interchanged as well. If this were given to you in the exam paper and the examiner made you solve this first, you can simply leave the answer as minus 63. But in this case, since I want to prove it to you, I will solve this part fully too. So the integral is 3x squared and the limits have been swapped. If we substitute the limits, the upper limit minus the lower limit respectively, so we would be left with something like this. And we have 12 minus 75 simplified, and thus we have our final answer as we expected it to be. So this was the concept. The limits being interchanged means the signs would be swapped. If the examiner makes you solve this first, he will assume that you know that the answer of this is minus 63. But in order to prove it to you, I solved it fully. That this rule is correct. Absolutely correct. Then, model 8 states that if we have something like this, notice that the upper limit of this is the same as the lower limit of this. That means that imagine we merge these, or rather ignore these, and adding these, if there's an addition sign in between, means that the answer would be AC. I know this sounds confusing, but I'll repeat. So we have the integrals of f of x, alright? The first part has the limits a and b. The second part has the limits b and c. Since there's an addition sign in between, we can write this down as this. And we know that this whole thing is equal to the sum of this whole thing. We'll have an example first. So let's move on. So we are given that the answer with the limits 3 and 2 is 7, and the answer with the limits 8 and 3 is 3. Notice that the upper limit of the first is the lower limit of the second. And once this clicks, you understand how you need to find or how you need to work in order to find this answer. So we can rewrite this as what we have to find in two parts. The first we're given is this, we know this, and we know this too. We know that the answer of this part is 7 rather, my bad, and the answer of the second part is 3, and the answer turns out to be 7 as we expected it to be. Another example, in this case you need to think before finding a relationship, and notice that the upper limits of these two are the same, but this rule cannot apply because pi should be the lower limit here in order for this rule to apply. So according to the preceding rule, if we interchange the limits, that is pi becomes the lower limit and 7 becomes the upper limit, we expect the sign of the answer to be changed as well. And now we can form a relationship using this and this. So we need to find this thing, alright, and we can split this into two parts. The first being this, and the second information we have is this. We know the answer of the first part to be 12 and the answer of the second part to be -4, and thus we have our answer as 8. So we finish up definite integrals here. In the previous video we introduced it to you. In this video we introduced advanced concepts such as the limits being interchanged and what if definite integrals are being added. Alright.